All right, guys, welcome back to our molecules lab. You should have the Google Doc open that looks like this, and you've got your Ziploc bag with your gumdrops and your mini marshmallows, and you have sorted them by color, And then you also have your toothpicks in a pile, all your supplies ready, and we're gonna quick set up and prep, and then we'll start working on our models. So we are going to be, if we look at our first instruction here, we are going to be making models of the simple and complex molecules that we would find in a normal can of soda. And by looking at Lewis structures, which are down here on our last page, we're going to be making models based on that. We can fill in the types and the number of each atom in the different molecules, and then we're going to decide what color marshmallow or gumdrop you're going to use and how many of each that you will need. So, in a typical can of soda, we have 4 primary ingredients. We have water, H2O. We have carbon dioxide, CO2. We have fructose, which is one of our sugars, which is C6H12O6, makes up fructose. And then we have caffeine, which is C8H10N4O2. Okay, so what we're going to do here quickly is we are going to outline everything that makes up these compounds. So in water, our first one is done for us here. We have hydrogen atoms, and there's 2 of them. We've got our subscript 2. So then decide, actually we'll do our colors afterwards. What other atom is present in water? Oh, oxygen. And how many of them? Just 1. Coming on down to carbon dioxide. We have C, carbon, and again, there's no subscript number, so there's just 1. Then we've got O2, oxygen, and we've got 2 of those. Fructose. We've got C again, carbon, and how many? 6. Our subscript 6. Then we've got H, hydrogen, and this one, wow, there's a lot of hydrogen in this. 12 of them. And then we've got oxygen and 6. And it's interesting because this ties into math and ratios, right? If we were to simplify our ratios here, we could really say that it's that. 1 carbon for every 2 hydrogens for every 1 oxygen, because 6, 12, 6, that would be our simplified way of showing fructose. Then down here to caffeine. Caffeine, carbon, how many? 8. Hydrogen, how many? Nitrogen, N. And we've got 4 of those. And then finally oxygen again, 2. So we have only 4 different types of elements rearranged in different ways to make different compounds. And so you now will need to count up how many of each color of gumdrop or marshmallow you have to make sure that you can stay consistent. So the highest amount is here in fructose. We need 12 hydrogens. And when I counted up my gumdrops, I could only use orange as my hydrogen. So because I'm using orange as my hydrogen here, I'm also using orange for hydrogen down here, and I'm also using orange for hydrogen here. Okay, so that's what is going to be my hydrogen. Now, I came down to my next number here, carbon. I need to have 8 carbons, and I counted up my gumdrops, and I only had 8 greens. So I'm going to use green to show my carbon, and so green becomes carbon here also, and green becomes carbon here. Then I come down and I've got 6 oxygens, and I look at how many gumdrops I've got, and I'm going to be using red to be my oxygens. And then finally, my last one here, nitrogen, I am using purple. Okay, so you're going to have to decide your own colors for each of these based on how many were in your bag. All right, so I'm going to give you time to do that. You're going to sort, you're going to count, you're going to specify your colors, and then we'll move on to making our models in the next video.